The manufacturing of an aero engine is an extremely precise engineering task. This is the manufacturing factory of Rolls-Royce engines. It only takes 20 days from the start of making the first internal module with the launched kit to the shipment of the engine. Among them, the fan blades provide 75% of the engine's thrust. When at full throttle, it transfers about 1.2 tons of air per second. Today, let's step into the Rolls-Royce factory together. From the manufacturing of the engine fan blades to the formation of various precision components, and then to the complete assembly of the engine, let's witness this amazing engineering wonder. Everything is assembled completely by hand and goes through thousands of hours of testing. Finally, it sends the aircraft up into the blue sky and white clouds. Therefore, the Rolls-Royce engine has become the engine with the highest flight efficiency in the world. This is a Boeing 787 Dreamliner. It is designed to be the most fuel-efficient large jet aircraft in history and is hailed as the future of air travel. After years of development, the aircraft was finally ready for its first flight in 2009. For Boeing, this was the first new passenger aircraft in a decade, and it was also a make-or-break moment. At that time, in the office in Derby, a large number of engineers gathered around to watch the live broadcast via the internet. No one was more nervous than them, because the groundbreaking jet engine installed on this aircraft was designed and manufactured by these engineers. The technology it uses will save £3 million worth of fuel for each aircraft every year. This Rolls-Royce engine is also claimed to be the most environmentally friendly and cleanest engine in the world. The engine incorporates some of the most advanced aviation technologies in the world. Rolls-Royce jet engines are manufactured in the most advanced factories across the UK. The orders are worth more than £40 billion. Just for civil aviation engines, approximately 11,000 employees are hired to build them. A new engine must roll off the production line every 36 hours. The main assembly plant of Rolls-Royce covers an area of 1.2 million square meters. This is the factory complex located at the southwest corner of Derby. For 100 years, this city has been the home of Rolls-Royce. For many people living here, Rolls-Royce is an integral part of their work and life, because the lives of the vast majority of them revolve around this factory. Many people have spent most of their working lives at Rolls-Royce. It's just like their family business. Their skills are passed down from fathers to sons and then from sons to grandsons. The whole family works here. As is well known, Rolls-Royce was once world famous for its luxury cars, but all that came to an end in the early 1970s. Today's Rolls-Royce cars are actually manufactured by BMW. The company's true legacy, however, lies in aircraft engines. They power some of the world's most iconic aircraft, from fighter planes in World War II and the Harrier jet to the much-loved Concorde. To this day, Rolls-Royce continues to power helicopters, business jets, military aircraft, and even large ships. The star products among them are the groundbreaking Trent jet engine series, including the Trent 1000 used in the Boeing Dreamliner. All Trent engines are designed for large wide-body passenger aircraft, such as the Boeing 777 and the renowned Airbus. But the engine used for the Airbus A330 is the best-selling one. This is the Trent 700. Over the past dozen years, it has accumulated 13 million flight hours. Each Trent engine weighs at least 5 tons. There are only 2 companies in the world capable of manufacturing such excellent engines, namely Rolls-Royce in the UK and General Electric in the United States. Interestingly, all the latest technologically advanced new aircraft choose Rolls-Royce engines to provide power for their maiden flights. The Trent 700 can carry a payload of 242 tons. It is like a beautiful work of art. However, initially, popularizing this engine was also the biggest challenge faced by the factory. With 400 new engines ordered, they had to produce at least 4 engines per week. This is also one of the most complex engine production lines in the world. Each Trent engine is built from modules, with 8 independent parts assembled together on the assembly line. But each module is composed of thousands of components. Everything starts from this huge parts warehouse. The staff need to deliver each engine part to the assembly line on time, even something as small as a nut. The contents in each small box here are worth no less than £1,000. The accessories of the entire engine control management unit are worth as much as £750,000. The total inventory on the shelves is worth £200 million. Arriving at the production factory of the fan blades, after the raw materials arrive at the factory every day, the workers need to operate the machines to finally transform this high-grade solid titanium plate into high-performance fan blades. The fan blades provide 75% of the engine's thrust. They transfer approximately 1.2 tons of air per second. When the blades are at full throttle, the load on them is about 90 tons of centrifugal load. This is like hanging 13 double-decker buses on 20 blades. The huge fan is what differentiates modern large engines from old-fashioned turbojet engines. Old-fashioned engines don't have a fan in the front and rely entirely on ejecting exhaust gas to propel the aircraft forward. They are faster than propellers but less efficient and very noisy. However, in turbofan engines, like the Trent engines, the energy harnesses the exhaust gas to rotate the huge fan blades in the front, thus pushing a large amount of cold air to quietly flow around the two sides of the engine. This is what propels the aircraft forward. The original blades used to be solid. However, in order to achieve better performance and reduce the weight of the engine, the blades of the Trent 700 engine are designed to be hollow. Each fan blade is worth as much as an ordinary family car. 3 pieces of titanium alloy metal are bonded together to form a more reinforced alloy. The entire bonding process is a closely guarded secret of the factory, and the cameras are not allowed to record the whole manufacturing process. When the 3 layers of titanium alloy are combined together, the entire blade expands and stretches like a balloon. The inner layer passing through the cavity is like the cheese between pizza slices, thus leaving an ultra-light and super strong internal structure. But before that, the flat titanium alloy composite layer must be heated and inflated to make it twist into shape. The workers need to be fully equipped in heat-insulating suits. A heat-resistant tube connects the blade to a high-pressure gas source, but the gas alone is not enough to make the blade expand. The entire assembly must also be placed in a furnace at a strictly confidential critical temperature. After 30 seconds, the workers must stay away from the furnace because the surrounding temperature is high enough to harm people. It takes 4.5 hours for the gas to slowly inflate the blade to the precise airfoil shape. Next comes the cooling process. Although the engineering is extremely precise, no 2 finished blades are exactly the same. Each fan has 20 blades. Only when the blades are perfectly balanced can it rotate smoothly. Therefore, each blade needs to be precisely measured and weighed. After that, they can be sent to the assembly factory for installation. Here, as many as 150 blades are shipped out every week, continuously ensuring the production process of Rolls-Royce engines. Rolls-Royce is a global company, and some components of aircraft engines are also manufactured and assembled in overseas factories. This is the purchasing department of Rolls-Royce turbines. They also need to source parts from all over the world, instead of producing everything on their own. It is believed that no large global enterprise can manage to produce and manufacture everything independently. One of the largest modular components is produced in a specialized factory just 80 kilometers away from the Rolls-Royce factory. This is where the large protective casing for the engine fan blades, also known as the fan case, is made. Its main function is to direct the air to the main core of the engine and provide a containment system. When the forging was initially made, it weighed 5 tons, but after completion, it only weighs 500 kilograms. So, it has to be processed to very fine tolerances, with a wall thickness of about 2.5 millimeters. A total of 40 processes are required, and the longest process takes 90 hours to complete. The steel shavings that are milled off won't be wasted either. Every precious piece of material is collected and recycled to make more components. There are more than 140 engineers here, including technical experts and those responsible for basic mechanical skills operations, such as turning and welding metals. One of the most experienced welding experts is Wilson. His job is to fix a ring of titanium alloy blades to smoothly direct the air into the engine. This is a highly specialized form of welding. He has been working here for 22 years, and almost all the engine blades have been welded by him. Every weld in this job will be inspected by X-ray, and any defects or flaws will be removed and repaired again. Wilson works here together with his son. More than half of the family's in. The entire factory work together. This is the tradition of Rolls-Royce. Everyone regards this place as their big family, and they have a high sense of responsibility. The core of each engine is a ring composed of 96 turbine blades. This is the most amazing component in the entire engine. A jet engine works by drawing air into its core and passing it through multiple compressors. The air is compressed to 50% of its original volume. This compressed air is forced into combustion, where it explodes together with fuel in the combustion chamber, generating a fierce jet of gas. These turbine blades rotate so rapidly that each blade can deliver the same amount of horsepower as a Formula One engine. The manufacturing process of the engine core, composed of these 96 turbine blades, is even more precise. The blades are constantly operating in a harsh environment. They must rotate at a speed of approximately 10,000 revolutions per minute, which is equivalent to running at a speed of 130 kilometers per hour. The component itself operates at a temperature 300 degrees above the melting point of the alloy, which is equivalent to 1,700 degrees Celsius. So, they must be designed in such a way that they won't melt. The designers at Rolls-Royce use computer modeling to design blades with precise patterns, and a cooling system is installed inside the blades. The energy taken away by this cooling system is equivalent to the energy required to boil a kettle in 20 seconds. But even with the cooling holes, ordinary metals won't work. That's when the Materials Research Laboratory comes into play. Here, they create new metal materials that fully meet the physical and chemical quality requirements of the designers. Using an electron microscope, materials scientists can accurately analyze the microstructure of the alloy and check whether the crystal structure and the metal mixture are exactly as expected. Even a finely balanced alloy formula is not the most advanced technology in the turbine blades. In order to cast the metal into complex shapes, they use a unique process, which is again a closely guarded secret. The blades are made by growing a single crystal of metal into the correct shape. This starts with a complex, handcrafted blade model. The secret part is the way the molten metal cools. Through a spiral tube at the bottom of the mold, the tube prevents all crystals except for one solid metal crystal from passing through, allowing this single crystal to grow throughout the mold. Once the shape is formed, each blade goes through repeated and thorough inspections. Each blade undergoes 4 days of precision machining, and due to the special requirements for the blades, their dimensions must be accurate to within 1/10 of the width of a human hair. However, innovation is a risky business. The huge investment in designing and manufacturing new engines almost brought Rolls-Royce to its knees. When the Lockheed L-1011 TriStar airliner equipped with Rolls-Royce engines achieved great success, the engine has since become the jewel in the crown of Rolls-Royce. To this day, the Trent still serves as the basic design for the entire series of large jet engines. This engine has helped them grow from a small enterprise into a global competitor, and it has been installed on more than half of the passenger aircraft. The value of new orders exceeds £40 billion. This is the engine assembly factory of Rolls-Royce. The core of the Derby factory is the main assembly line for all Trent engines. The production line must operate like clockwork, starting from the very beginning to assemble each component to complete the engine assembly. Here, it only takes a short 20 days for an engine to go from the manufacturing of the first internal module to leaving the factory. First, the assembly begins with the largest and most complex module. Hundreds of precision blades are all assembled by hand. 4 days later, the work of installing the Kevlar-wrapped aluminum fan cowling of the engine starts. More than 4,000 control units and transmission components are installed and wired, and all these tasks are also completed manually. At the same time, another group of people assembles the 8 independent modules of the engine together. Each module fits perfectly, and then the fastening screws are installed. Each screw is adjusted to the precise torque. There should be no bumps or scratches during the entire coupling operation process. Otherwise, it will need to be redone and repainted. The huge fan blades are installed. Just one fan blade is worth as much as a family car. Up to to this point, the entire fan component is installed. Now, the engine unit is hoisted to one side. Next, it is hoisted horizontally. 2 tons of precious metal swings just a few feet above the ground. The engine is ready for the last 2 largest modules, that is, to connect with the fan module. After 2 weeks of assembly, each completed engine is equipped with a huge aerodynamic duct and is slowly transported to the specially built flight test center in the factory. It will be tested for operation under the harshest simulated flight conditions. Engineers monitor data such as its vibration, rotational speed, and temperature to ensure that everything is running normally. This is just the most preliminary test. There are more challenging tests before the official delivery. They need to conduct thousands of hours of testing to prove that the engine is airworthy. For each latest design, it may take 2 years of testing time, which includes cold starting under the condition that the temperature is as low as -40 degrees Celsius, as well as the water injection test. They inject water at a speed of 30,000 gallons per hour, and the engine must not lose thrust. This test needs to prove that it can deal with rainwater and hail, and the compressor can handle the amount of water passing through the engine. In addition, there is the impact test. It is shot from a disc at the maximum takeoff speed and shot into the fan casing. This kind of test is very expensive, but the absolute safety of the engine must be ensured. After the test is completed, this engine is declared scrapped. Only by sacrificing the entire engine in this way can they be sure that the fan case is indeed functioning properly. Only when all the data are without problems can the engine be delivered to the customer. That's all for today's video. If you like this kind of video, you are welcome to like and subscribe to the channel. See you in the next video.